Thank you very much. Hello, everyone. Welcome to the talk. Indeed, we'll cover some of the Elastic basics. So if you haven't seen much with Elasticsearch before, you'll get a quick introduction. But if you have, there's also a lot of the newer stuff that I will be addressing, especially the large language models and all that. But let's start from the beginning. I'm Iulia. I've been in the Netherlands almost 9 years now, I think. I studied here, and now I live and work in Amsterdam, currently at Elastic. And my role is developer advocate, which I didn't know existed before I got this job. But basically, I did a few different types of roles in IT, from like data scientist to architect to sales engineering, even, which, sales wasn't the best choice. And now I'm back here, and my main role is to create content and to make the products easier to understand and to make cool use cases out of them, which I love. So that's why I'm here. This may be one of the first questions you would ask yourself looking at the talk. Why Harry Potter? Well, on one side, because I can talk about Harry Potter for a living, so why not? I'm a really big fan of it, but I also think it's just a domain that a lot of people know, so then it's a lot easier when you make examples to understand if it does work or not, or if it makes sense or not, if you're familiar with the material, rather than just picking a random database. And also because the books are so popular, but they're also so much data. Like normally when you say data, especially like from the olden days in data science, you only think databases or columns and text, but the coolest innovations are kind of happening with text. So if you look at the books as just words and sentences and pages, you get a lot of really cool data that you can do a lot of cool stuff with. One of which this is an example I always give in my introduction to AI or data science sessions I do about translation. So how do computers translate books? Is it like the way the humans do it with artificial intelligence, that you learn the grammar and you put the sentences together? Not really. They just look at a lot of examples and they're told this page is the same as that page, which you see here. There's one in English and this one is my book in Romanian. And you tell the computer these are equivalent, so then it kind of learns that the same sentences appear together. So if someone wants to translate a sentence later, like, what do we have there? Director of a firm. And if you ask, okay, what's that in Romanian? It can go to, for example, the Harry Potter books and see, well, a previous translation put it as this, so there you go. So it's just mimicking the way that translations work rather than just doing it, which is really good to understand for when you want to do cooler stuff with AI. And this is also a really nice example that I like. This is a tweet from 2017, back in the day, back around the time when I was also writing my thesis on working with NLP and data science. And they wrote a new Harry Potter book. Like they had a computer generate a whole new book based on the previous ones. And back then, this was like mind-blowing stuff. Today, maybe not so much because you're all used to ChatGPT and all the amazing things that can do. But in 2017, when they just started with Word2Vec and the very first examples of that, it was insane that a computer can generate sentences that at least make sense. Maybe not from a content, but like structurally they made sense. And we've come a long way from there. And yeah, today I'll show you a few examples of what we can do with large language models and Harry Potter today. But the other part of the session is about the Elastic Python client. And the reason that I'm discussing this is I joined Elastic last August. And as a Python developer and as a data science person, I tried to find my niche within Elastic of what I can build in there. I think a lot of people use Elastic quite differently. Have you guys used Elastic before? Maybe hands up if... awesome. Okay, so you know a bit about it. For those who don't, so Elastic or Elasticsearch, what you would most be familiar with is a search engine that's really powerful for finding data really quickly, and you can make a lot of custom queries and different parameters and filters to find data really quickly, which is a great way to look at your data and to explore it. But since then, Elastic also does a whole thing of observability and dashboarding and monitoring and security and lots of other things. But I wanted to focus on the search because it has the data sciencey elements in there. And then I discovered there's a lot of clients, whereas, maybe subjectively there shouldn't be so many. It's a bit confusing to get into it and to understand. And as I was going through all the beginner tutorials, I thought, okay, maybe this could be a bit clearer, and that's why I'm making this talk. The first Elastic client, when you just look it up, is probably this one. If you work with Python and Elastic, this is probably what you're familiar with as well. It's the Elasticsearch client. It's a low-level client, it's easy to install, and then you basically make the same queries that you would, like the queries are made as JSONs. We'll look at a few examples later. And basically, any single language you can put on top of that, you take the same query, the same like squirrely brackets with info in it, and you send it to Elastic. This doesn't add a lot on top of that. On the other hand, we have the Elasticsearch DSL, which is basically taking the first one and thinking, okay, but I don't want to write this whole thing all the time, so I'll just make some extra functions to make it easier and to reuse. And it ends up looking more Pythonic, but at the same time, it's less reusable if you want to use the same query in a different language. For those who prefer the visual learning experience, this is what a query looks like in the main client. So again, you have the query, which you can take that and put it in the dev terminal directly. That's usually how people interact with Elastic. You can put it in the Java language, in any other tool, it will work the same. And this is what it looks like in the DSL. So it's more, code rather than here's this big chunk I'll surround with like just one line of code. So there's benefits and drawbacks to each of them, depending on what you want to do. If you want to create a cool, fun demo for a conference, you'll probably use the main one. But if you want to put something maybe in production or you want to make it look neater, a lot of people also use the DSL. I see it as working with notebooks versus working with classes and making files and complex projects. So I personally mostly just use the main client. Also makes it easy to go, cell by cell and have everything be isolated. So you would think, okay, it's 2 clients, it's not that bad. There's a third one. We also have Eland, which is an Elastic client specifically for the data science part. Has anyone worked with data science in Elastic? Show of hand. No? Okay. So if you are interested in that, a lot of data scientists use Elastic for monitoring their models because there's like a lot of data coming out in the behavior of, the predictions, data comes in, data goes out. So Elastic is a really great tool to go through those logs. It's the same use case as using it for security, right? Whenever you have incidents and stuff, you can go through them really quickly and get out just the important information or even automatically trigger anomalies or peaks that shouldn't be there. And Eland allows you to first work with data frames, which is what people who work with Python mostly use as a data structure, but also to import models into Elastic. And that's where like the really cool stuff is happening and what like the newest and nicest thing we do is. Have you guys worked with large language models? Do I need to introduce the concept? I've worked with it, hands up. Oh, awesome, great. So then you're familiar. Basically what we can do, and I think I have this here, is if you know Hugging Face, it's like this library of models where all the cool, greatest models are. We don't want to reinvent the wheel. So what you can do with Eland is just, say, I want these models, take them, put them into my Elastic cluster. They are all pre-trained, so you don't have to use the compute power to train them or to tune them yourself. They just kind of work, and they're all open source. Well, I think not all of them, but some of them. And you can put them into your cluster, and then you can add them to your search. So all the great searching capabilities you already had with like filtering and super, super fast response times, you can now add a semantic layer on top, which is really useful if you work with data like the Harry Potter books or whatever kind of text information you have, like customer reviews or Twitter tweets or whatever. There's like a lot of use cases for that. So to summarize, before we go into the demo, we have the Harry Potter because books, they're nice data. You'll probably understand the example I give. Then we have the chaos that made me want to make some nice beginner tutorial. And everything here is on my GitHub as well, by the way. There's like 10 notebooks of all the layers of what you can do with Python and Elastic. And then we're adding in LLMs because they're cool and everyone's talking about them now. So what does all of this look like? Let's go over here. So we have Elastic. I use the cloud version because I'm like the fun data science kind of developer, not the install things on my machine developer. But you could totally do that as well. It all runs locally as well. And this is Elastic. Again, you guys said you kind of know it, but just to do like a quick intro, you can make dashboards as part of the observability thing. This works. Let me make sure my hotspot is still on. It is not. Basically, yeah, you can make dashboards, which will load in a second, which is very similar to like any other BI tool. So it's nothing like particularly revolutionary. This happens every time you do a demo, doesn't it? Yeah, it's coming. And basically, you can just drag some data in there and make some nice graphics from it. I got this data set from Kaggle, which, again, data scientists, they always get their data from Kaggle because there's all these like really nice, clean data sets to work with. And it's like all the Harry Potter characters with some properties, which is great for searching through them. So I have like different graphs that I made in here, and they're interactive, so you can apply filters and propagate it to the rest of the graphs. And this is the first kind of step of searching, right? So if you're searching to find a particular point in your data, this could be a way to do it. It's a bit unconventional maybe, but by just going through this and you say, okay, I want a pure blood that's in Slytherin, and then you get 11 people. So you can drill down by just putting filters, and this is a way to do it visually. And you see they kind of just appear here in this syntax language. If you want to go one step further in your search, you can use this Discover tab, where I have my data set, and again, every single document you can see is like a collection of information about a certain person, and I can filter it the same way. So if I say, what was it, blood status, pure blood, and I do this, then it will also narrow it down for me. But it's important to note that even this has limitations. Like, for example, if I put it like this, it doesn't work anymore because I didn't use the exact filter that I needed. And if you've ever worked with data, you know that it's almost never, perfectly clean. And you could spend the time to get it into that shape, but especially if we get more complex data, like we had a few fields in here that described the job of the people, then they might have like slightly different names or slightly different words to express that. So we need something a bit more comprehensive for today's search. Like if you think of searching on a website, you might not know the exact words and you still want the best, most relevant result to come up. So that's where we take it to the next level, which is adding NLP models. So NLP, natural language processing, there's a lot of cool stuff you can do with that, starting from entity recognition, so just like picking up names or personal information that you want to hide out from a data set. There's like embedding models, which put all your data into this multi-dimensional space that allows you to compare things together. Like you can compare, the classic example from Word to Vec was you have king minus man plus woman equals queen. So you can do this kind of math and apply these rules, but in a semantic dimension. And then you can classify things as you can do sentiment analysis, which we'll show in the demo, and many others. And if you make enough of these and put them together, you will end up with a tool like ChatGPT that can understand humans. It doesn't really, but it just has enough examples and enough embeddings in a natural space that it can mimic human speak, so to say. So we can add these into Elastic as well to make it part of our text analysis. And for this, we have a different data set that is basically just the scripts of the movies. So I wanted the books, couldn't find the books because there's like, copyright and whatnot. But you can get the scripts of the movies, which are pretty much the same thing. You have all the dialogue in there, and then you can search through that. So if I go to an example, in the Harry Potter books, if I search for blue eyes in here, we get these text fields that have mentions of those words. And here we have blue eyes exactly like the way that it was searched for. His blue eyes, deep blue eyes. There's like a lot of more examples that come up. And we can do that with more complex queries as well. Oh, and I didn't actually show you guys the Python part. That was the whole point. So we have the way that the clients work is the same thing as doing it in the dev console. So that was the one that I just showed you, where, spoilers, if we have this search that we do in the dev console, which was just putting the queries in there, then the same thing can be done in the Python client. And then the benefit of actually being in Python is that you can, well, let's get rid of these. The benefit of doing it in Python is that you can then process the results, because as you've seen, the results in Elastic are like this whole thing that also tells you how fast the search was and what cluster it ran on and all these things that you don't necessarily need. But processing it in Python allows you to just get back the exact name of the document or the property that you want. So I always prefer to do it with the client. And you can also make as complex of a search as you want. Again, it's basically just copy pasting the same query into your client or into the dev tool. And you can make them more or less Pythonic, so to say. So you see here we have query as an element, but you can also go one level up and just say body. And then you also put the query in there, or you put a different command in there. So there are ways to use more parameters versus just using the JSON, but this just makes it more reusable. So then what we can do, as I was saying, with the machine learning models is, I don't want to go too fast, you have the client. This is what it looks like. All you have to do is connect to Elastic. In this instance, I'm connecting to the cloud. So I just use my cloud ID and my API key, and then I can interact with it the way I would in the dev console. And this is the part where we use Eland. Basically, then we take those models from Hugging Face based on their ID, and I say add that to my cluster. And in this case, I'm doing an embedding model, and I'm doing a sentiment analysis model that I can then use in my search. So then basically, this is what it would look like in the dev tool, and it's the same thing that I'm going to use in my client. So I have here an example. I'm just taking the ML models. I say I want this model and just add it to my cluster. And then we can see like the information that it got successfully put up there, and we can use it if it works live. Of course not. Why would it? Connection timed out. Awesome. Let me make sure that this runs. The model body. Yeah, this still works. So the model has started behind the scenes, is powering up. At least, you know, it's a live demo. I'm not faking it for you guys. And basically we have different documents. There you go. I didn't import any data. But we have one document at a time that we can send in and ask it to perform that model on it. Any sentence that you want to test out the sentiment of to make it realistic. This session is going great. There we go. Positive. So this is how this works with the models. Basically, it's like an API call the way that Elastic also works as well. So you can then use these models through Elastic. It's going really bad. Just double check. There you go. Negative, which is fun by itself to use the sentiment analysis. But what I then want to do is just apply this to my entire data. So you can make these pipelines, which again, if you're familiar with Elastic, is just saying for all my data, make this construct that all the sentences come in, and I'm using the model, in this case sentiment, apply it on every single sentence, and then I get a result, and keep that in my index as well, so then I can later on use it for my search. So once all of these are put in there, these are the first sentences from my first script, followed by the sentiment. So now my data has been enriched with this embedding layer where all the sentences have this thing. So of course, the next step, at least in my head, was what are the most positive and the most negative sentences in the books. And I have them here, but I also have them on the slide just to see them a bit better. So these are the most negative lines in Harry Potter, if you've ever wondered. So again, this like embedding dimension allows you to compare what is more negative or less negative and what is more positive or less positive. And these models work quite well because they've been kind of perfected a long time. And this is now something that I can include in my search. So I can search not only for blue eyes or magic, I can search for positive instances of when that was mentioned or negative instances of when that was mentioned. And then going one step further, rather than just search for the keywords, which is what Elastic normally does, I also want to search for synonyms or for meaning. So if I look for magic, I want spell to come up and wand or whatever. It'll probably be the whole book coming up. But, you know, if you have a specific search, you can use that layer. And then especially when you put them together, you can search for positive instances of magic and negative instances of magic. And then you start to get some more interesting results. So to show that, we also have this embedding model, the same process. We're connecting to our Elastic cluster. We have some documents that we put in. Our Docker will bring in a new model and add it to our data set. So now when we use, these are all the models that I have in here. And the same thing, we can put in the model and we can put in any sentence and it will be transformed into a vector. So again, I can change this and say, my name is Iulia. Doesn't really matter if you misspell it at this point. It just gets transformed into this embedding space. So this is a bit less intuitive than the sentiment one, obviously. You just see all these numbers. But basically what this allows you is then when you have a query and your entire books have been converted in this language, then you can easily search like which vectors are closer together. So I do that once again with a pipeline. I apply this model on my entire book. So then when you look for something, I have a few examples here, you can then find all the related terms. And these are just some that I picked. Again, if you want to shout any other thing you want to search for in the books. Awkward silence, okay. Then you can create this search engine that just looks for that. And for each of my questions, I can get back like the top results that are similar to that. So I have magic spell, I think was from a previous session. And you get back things like spell, so the same word, but you also get back words that aren't in this query. Yeah?
Search for awkward silence. Right.
Sure. Let's change the first one to awkward silence. There you go. So then if I search in here, quiet, be quiet seems very quiet. So quiet is related to silence. I guess it's not, I don't know if anything's awkward in the books. Well, they are teenagers, so I feel like there should be, but yeah. So there you go. Like it understands the context of the books, but also just the context of language overall. So that works the way it does. You'll also see that sometimes it seems to perform quite badly, like the most related words to Harry Potter are, Harry Potter. And that's because of overfitting, which we deal with a lot in ML, where it's like the exact same match. But that's why we use Elastic to tinker with it, and we can then start to tell them, I want like a specific kind of search. So what I did next is, I'll skip over this because you've already seen the whole thing, but we basically put the models together. And then if I search for example, the word brave, I get these sentences where sometimes I see the word brave, sometimes I see the word courage, bravery, and so on. And again, I'll switch to the slide so you can see it a bit better. But yeah, basically, I'm looking for brave. Okay, maybe I want to narrow it down a bit more. So I say I want to look for brave, but with a negative sentiment. And all of a sudden, my search turns into risk and fear and coward and fear. So, fear comes up a lot. Again, because I'm using what I would now call hybrid search, I can also use the filters and all the other native capabilities of search to say, exclude the word fear, because it's, it's a bit much, too much of it in the search, and then you get more varied responses. You still get fears, because again, the keyword search is precise, whereas the semantic search is a lot more varied. So yeah, this is just an example of how you could combine all these things to come up with more complex ways to search exactly what you want in a book. And of course, you can apply this to other data sets or examples as well. So to summarize the kind of technology that I've used, and yes, this is more of a photo slide, we have taken advantage of the fact that Elastic is a vector database. So it's very easy to store those really big vectors we've seen in the embedding models. So like those really, really lots of numbers that represent each sentence. You want to be able to store that in a way that you can like quickly go through and compare them amongst each other with all the math that is involved. So you can create the embeddings and you can search through them. We've added the elements of machine learning to it. So the models that we can bring in from Hugging Face or your own models or whatever you want to do. So you can add sentiment, classification, recognition. There's like a lot of things that you can do. And you can layer them on top of each other, which then creates semantic search. So you have all the good parts of tuning your search the way you want. And then you have the semantic element, which makes you understand it a lot better. And that's also something that is natively available in Elastic now, but that's like one of the paid versions, so I didn't really want to use that. But you can still make it yourself with just adding the right models and combining them the way that you would choose to. So yeah, another final photo slide. There's a lot of Python clients. They have their uses. If you're working with Python Elastic, you can use these to just make a search application, or you can use stuff like eland to make semantic applications. And a final acronym is ELSER, which is what I just mentioned, the semantic search model that just does this by itself, so you don't have to deploy the models and etc. So yeah, you can make it as DIY as you want or out of the box. There's a lot of flexibility and I think it's fun to play with, and that's why I did it. And that was it. Thank you.